Good morning, children. Last class we discussed about some properties of the materials, isn't it? That time I told you that some substances or some materials are soluble in water. So that time I forgot to mention about the gases. You know the gases like the sugar, like the lemon juice or like the honey. Some gases also completely dissolve in water or mixes with the water. They are oxygen, carbon dioxide and nitrogen. These are the examples of gases: oxygen, carbon dioxide and nitrogen. These are the examples of gases that can be completely dissolved or mixes with the water. It is because of that reason you know that so many organisms live in water, isn't it? You know that fish are there, and whale. Of course, no, whale is a mammal. I'll discuss later. No blue whale. And likewise, so many plants are there. They all live in water. And we know that without oxygen, organisms cannot live. So how do they breathe? They breathe the oxygen dissolved in water. In the water, oxygen is dissolved. Fish open the mouth all the time. Have you observed it? Yes, the water enters through the mouth, and it takes in the oxygen that is dissolved in the water. So these are the examples of gases that dissolve in water. What are they? Oxygen, carbon dioxide and nitrogen. Clear? Okay. Now we can move on to the next session. You know that materials are made up of, all the materials are made up of matter. Whether it is a gas or whether it is a solid or liquid, whatever materials, they all are made up of what? Matter. Then who can tell me what is a matter? All the materials are made up of matter. Then what is a matter? Matter is a substance that has got mass and volume. Matter is a substance that has got what? Mass and volume. What is meant by this mass? It is the weight. If any object has got weight, or if what is volume? The space it occupies. The space it occupies, that is the volume. You know I am a matter. You know why? Because I have got weight and I need a space. You are also a matter because you're sitting and watching the class. So you need a space, isn't it? You need a space to sit, and you have got weight also. And this weight doesn't change. Of course, when we go to space, our weight also changes. That is another thing. But in the earth, wherever we go, our weight doesn't change at all. In the earth, in this planet, some of you have experienced that when we had gone to that planetarium, you had seen that different planets, our weight changes. Some students, they had experienced it. When we go to different planet, our weight changes. I'm talking about the earth. Wherever we go, in any part of the earth, our weight doesn't change. Our volume also doesn't change. Same place only we require. If you're sitting, you need a particular place. While we are starting, we need a particular space. Thus, our volume is not at all changing, and our mass does not change at all. Mass means what? Weight. Weight. You know what is weight? Yes. And 1 kg sugar, likewise, we have also got weight, 20, 30, 50, 60 kg weight we all are having. So that is the mass. So any object or any material or any substance that has got mass and volume are known as what? Matter. 1 mark question. Any substance that has got mass and volume, such substances are known as what? Matter. So this matter, they are made up of molecules. The matters are made up of molecules. Molecules are tiny substances. Tiny means what? Very, very small substances. Matter is made up of very, very small substances. Matter is made up of very, very small substances known as what? Molecules. This is a paper. We just see this is a paper. Clear? Yes. When I tear this paper, just see, even the smallest, when I tear this paper, the smallest piece, also has got the properties of the paper. Couldn't in a small piece, again I can tear this and can make into smaller pieces. And even the smallest piece, they also has got the properties of paper. When I tear the paper, the smallest piece doesn't become wood or plastic or metal. Hope it is clear. This is a paper. When I tear the paper, it becomes the smallest thing. The smallest thing or smallest piece of paper also has got the same properties of the paper. You know, when I burn it, it catches fire easily. When I pour water, it gets wet easily. I can tear it, isn't it? All the properties of the paper is similar to the properties of this smallest piece of paper. And when I break the glass into pieces, even the smallest piece of glass also resemble what? The features of the glass. Because they all are made up of similar type of molecules. Even molecules, we know the smallest substances that you can't see with the help of our naked eye. But since we couldn't see, but still we could understand that the smallest particle of any matter is similar to the largest part. Smallest as well as the largest part, they have all got the same properties or they all are similar. So matter is any substance that has got weight or mass and volume are known as matter, and matters are made up of molecules. Molecules are the tiniest or smallest substances that are seen in a matter. Clear? We can't see the molecule, but still you could understand that the smallest piece of any material or smallest part of any material is similar to the largest part. You know sugar. Even the tiniest part of the sugar also tastes sweet, isn't it? Does it taste salty? Does it taste bitter? No. The smallest piece or smallest part of the salt or sugar or whatever it is, the taste will be same as the largest part. Clear? Yes. That is the peculiarity of the matter as it is composed of what? Similar molecules. Okay. Now we can move on to the different types of matters. Some of you may say that because you have already studied about different states of matter. And what are the different states of matter? Who can tell me the answer? Yes, very good. Solid. Next one, liquid. Third one is the gas. Solid, liquid and gas. These are the three states of matter. Clear? Yes. So you all are familiar with all these terms. Solid, liquid and the gas. I hope you all are familiar with it. And first we can discuss about the solid. You know, in the solid, the example of solid, it's a book. Just see, this is an example of solid. And you know that this solid, it has got a particular mass or the weight. So we all know that the weight of the book has got weight. And the space it occupies also, that is the volume. So the solid, it has got a particular mass and volume. Wherever I carry this book, if I keep it on the table or if I keep it on the chair, if I keep it in the bag, does the weight of the book changes? No, absolutely not. It doesn't change at all. And what about the space it occupies? If I keep on my hand, the space it occupies. When I keep on the table also, the space or the volume it occupies doesn't change at all. That is the peculiarity of what? Solid. And one more thing, it has got a particular shape. Clear? All the solid substances, it has got, so this is an example of what solid. It has got a particular shape. And another thing you could say, this is an example of solid. It has got particular shape and mass and volume. The solid has got what? Typical shape, mass and volume. The case of solid, they have a definite or say a definite, that means what? It doesn't change. Well, if I take this book to the school, if I take this book to any part of the world, the weight of the book, this book I am talking about, this book doesn't change. And the volume also doesn't change and the shape also doesn't change at all. And I couldn't easily separate separate this book? Can I just separate this book? Of course, when I tie this, we all know it, I can separate. Otherwise, no. Can I separate this book? If I keep the book on the table, does it run from there? If I keep it on the floor, does it move away from there? No. Because it occupies, because you know why? These are made up of closely packed, you know, as I told you, molecules. The molecules are closely packed, very tightly packed, without leaving any. This is an example of solid. You could see that the molecules, no space at all. These molecules are very closely packed. In case of solid, the molecules are very closely, or otherwise we could say very tightly packed. No space in between. So no freedom is there for the solid. You know, the molecules are very tightly packed, very closely packed. In this picture, you could see that there is no space. The molecules are very tightly packed. So there is no space, or the molecules are not allowed to move anywhere. That much close the molecules are arranged. Clear? It is because of this we could say that this solid has got a particular shape. It is because of the close arrangement of the molecules, the solid has got a particular shape. Now we can move on to the liquid. Liquid also has got what? Mass and volume. Mass and volume same. Mass and volume doesn't change at all. But what about the shape of the water? You know that, yes, I have. What about the shape of the water in this bottle? It's the shape of the bottle, isn't it? Yes. When I say, if I ask you, what is shape of this water? Then you may say, it's similar to the shape of the bottle. Hope you have seen it. Now, if I transfer this water into this glass, then what will happen? Then if I ask the same question, then say the shape of the water. Yes, the shape of the water is similar to the shape of the glass, isn't it? If it is in the bottle, the shape of the water is the shape of the bottle. When I pour the water into this glass of water, then what happens? When I ask you, tell me the shape of the water, then what will you say? Yes, the water shape is similar to the shape of the glass. Clear? Yes. But in the case of solid, it is not like that. You know, solid, wherever I keep, the shape doesn't change at all. You know why the shape of the water changes? You know, when it is in the bottle, it is this, you know, when it is in the bottle, it is this shape. When it is in the glass, it's the shape of the glass. Then why is it so? Can you tell me? Then what about the arrangement of molecules? Just imagine this is the liquid, and you know that they are free to, some molecules, or the molecules of water, they are free to move. The molecules of water are free to move. When I pour the water on the floor, when I pour the water, you know, pour means what? Purikya. When I pour the water, what will happen? The water flow. We all have experienced it. During rainy season and all know, you could see that water is flowing. Does any solid substance flow? Of course, sand is a solid, but water can carry it. Otherwise, no, the solid substance cannot move as alone. Water can carry it, you know, due to heavy flood. No, you have already seen that the water can carry the, you know, big trees, houses, everything, and even the human beings can be carried away by the water. But of course, it happens in rare conditions. But these solid substances, they cannot move alone. They need a push or sometimes otherwise pull, or something should be there to carry it. But in case of liquid, when we pour the liquid over the floor, it can be easily flowed to a particular area. Clear? That is about the liquid, because the molecules are loosely packed, or they are free to move. That is in the case of liquid. Now we can move on to the gas. Gas also has got particular, mass is there. But, the volume is not there. Because the gas can spread like anything. The cooking gas. If the leak is there, you can sense the smell. If you sit in the sit out or in the drawing room, even though the gas is in the kitchen, you can sense the smell. Am I right? Because the gas is the cooking gas is a gas, so the gas can spread throughout the available space. Not only that, incense stick, chandanatiri, when we burn it, the fragrance, nice smell is there. It's a fragrance, nice smell, and that smell can be spread throughout the room to make the room fresh. Nowadays room fresheners are also there. That's a gas, isn't it? It can spread throughout the room. That the water changes into gaseous form. That all out, that liquids and all, that changes into gaseous form. Clear? And this gas can spread throughout the room where we are sleeping. So it can give protection from the mosquito bite. So the gas, of course, it has got mass, but it does not have any volume or the shape. It can spread throughout the area wherever it is there. Sometimes you may feel the foul smell, maybe the smell of any bad object. Even though you're sitting in the around houses, the smell, you can sense the smell. If someone is burning the plastic, even though you couldn't see it, but through the smell you can sense it, someone is burning the plastic. Because when plastic burns, the gas is evolved, carbon monoxide is evolved, or the gas releases from it, it is dangerous, and we can easily sense the smell. In kerosene smell also, when we burn, smoke, it can spread in the air. It's a gas. Clear? Yes. So these are all examples of gases. That molecules of gas are completely free to move. They can move wherever they like. The molecules of gas can move wherever they like. No control over them. Wherever they like to move, they are free to move. But so the gas has got particular mass, but no volume and shape. We cannot measure the volume of the gas. When it is released, definitely it can spread throughout the place, throughout the room or throughout the hall, wherever it is. So then why we are burning the incense stick evening time, or that to make the house completely feel fresh because of the good smell or the fragrance of the incense stick. Along with lighting the lamp, Hindus they used to burn this incense stick also to give the good fragrance throughout the room or throughout the house. Evening time also to kill that mosquitoes and all. Also some people are burning that. Some objects are burning to give the good smell, that it can freshen the room. Air fresheners are there. There is an all out to kill the mosquitoes. They all are examples of gas that spread. Even though all out is a liquid, but it changes into gaseous form. So these are the three examples of matter: solid, liquid and gas. In solid, molecules are very tightly or closely packed. They have shape, mass and volume. Very, very important. The molecules are very closely packed. They have no freedom to move at all. And they have particular shape, mass and volume. When we come to liquid, the molecules are loosely packed. They have some freedom to move, and they have particular mass and volume. The volume of the, as I told you, the volume of the liquid doesn't change. If I pour whole water into this glass, the volume doesn't change. Depending upon the shape changes, depending upon the vessel that we are filling the water. That's the only difference. And when we pour the water on the floor or anywhere, it can move also, it can flow. So because the molecules are freely, so the matter, liquid, they have particular mass and volume, but there is no particular shape for the water. Next we can move on to the gas. Gas has got mass but no volume and the shape, because it's spread throughout the place where it is, because the molecules are completely free to move wherever they like. So you can expect the question, why you are using incense? What happened to when we burn the incense stick, what happened to the fragrance? The fragrance spread throughout the room. Fragrance means what? Good smell. It spread throughout the room. When that when the jasmine and jasmine flower, that when it blooms at night, we could feel the smell, isn't it? We can sense the smell. The smell is a good fragrance, right? So we can sense the smell, because this smell is a type of gas. It can spread throughout the area. Clear? It's because the molecules are completely or loosely packed. So I can just compare it with you. You know that while you are in the classroom, your freedom is controlled, isn't it? You want to sit in a particular place and you are not allowed to move around in the class, isn't it? That time you can compare yourself with the solid. No freedom, completely under control. But once you are out, so you are the solid form. Once you are out for PT, that time you are in the form of liquid. Because you have some freedom, isn't it? You can move with your friends, but you have no freedom to move out of the school campus. Clear? That time you resemble the liquid. Then what about the gas? After the class, after the final bell, you are free to move into your own houses. No restriction there at that time. You all are free to move, isn't it? Even though you are with your friends, till the last bell, afterwards, no, you all say goodbye and you all move to your own houses. That time you are just like the gas, complete freedom. Clear? Yes, solid, closely packed. Liquid, some freedom is there. Gas, completely free. Clear? Yes. So the very, very important thing for the examination, you are supposed to write about the features of solids, features of liquids and features of gas. I hope it is clear. Now we can move on to the last section of this chapter. Classification. What's the importance of classification? Why we are classifying the substance, or based on what? Classification based on what? Based on the properties of the substances, we are classifying the substances. Properties. You know, you have studied about different properties of the materials. Who can tell me some substances? Hard, yes. Some substances are soft. Some substances with lustrous, very good attractive appearance. Some doesn't look attractive. Then, yes, some may sink in water. Some substance may float on water. Then, some are transparent. That means we can see very clearly through it. Some are opaque. Cannot see anything clearly. Some are translucent. Some light can pass through it. Next, some are good conductors of heat. Some are poor conductors or bad conductors of heat and electricity. Next, some are soluble in water. Some are insoluble in water. Some liquids are miscible. Some liquids are invisible. Clear? And based on these all properties, we are classifying the materials. You know that all the metals, first we discuss about the metals. What are the properties of the metal? Who can tell me the answer? Metals are good conductors of heat and electricity. Yes, then. Metals are lustrous or shiny. Very good. It can be polished. Another property of metal is that they zinc in water. All the metals, they zinc in water. These are some of the properties of the metal. Then what about the wood? Wood is a poor conductor or bad conductors of heat and electricity. Next one. Is wood shiny? No, but still we can polish it, isn't it? We can cut and polish the wood. Next one. Does it sink or float on water? Yes, absolutely right. Would float on water. So these are some of the, based on some of these properties, we are classifying the objects. And not only that, when we go to any supermarket, for buying specific thing only we are going there. If you want to buy the biscuit, you will go to the biscuit station. You know, the saleswoman or salesman may say that, no, when you ask, I want to buy the biscuit, then they may say that, in this row or in this rack, the biscuits are kept. Then when we go there, we could see varieties of biscuit. Then we can select the biscuit that we want. Some people, they want to see the price of it. Some may see the quality of it. Some may see, some of you may want chocolate, some may want orange cream, some want pineapple cream. So all these types of biscuits are kept in one rack on. And if you want to buy, you know that if you want to buy the soap, then they will say that the soap is in that rack. So you can see different types of soaps are kept there, isn't it? Different flavored soaps are there, different sizes of soaps are there, isn't it? So you can select which one you want. If you want the coconut oil, then they may show you, yeah, different types, companies' oils are kept there. So what is the use of this arrangement? Who can tell me the use of this arrangement? Yes, we can easily go and take it. Otherwise, just imagine now, one biscuit, then all are kept together. One chocolate biscuit is kept in one area, and along with that, no soap is there, along with that, soap powder is there, and coconut oil, everything. And another area, no, likewise, no, completely in disorder manner. If you want to buy one thing, you need to go everywhere. Do you like to go to that supermarket again? No, you may say that, no time. You want to spend more time there, isn't it? No arrangement. Nothing is there. Simply, no, one is there, no, I don't want to go there. But if it is arranged properly, if it is neatly kept, you feel like to go. You feel to go there and buy the things. In some I don't know whether you have observed or not, in some vegetable and fruit shops, you could see that, how beautiful they have arranged the fruits there. When we see, and even though we don't want, we like, sometimes we may got attracted. Some apples, beautifully kept, oranges, designer manners, some may just keep green, orange, different types, red and all, in a beautiful manner they have arranged it. So it attracts the customers. Even though we don't want, definitely sometimes you may be attracted towards it. Vegetable shop also, somewhere you can tomato, cucumber, all are kept separately. It helps us to take it as we want. At home also, classification is very important. When we open the mirror, you know that you have the uniform, you have the house dress, you have the dress that you used to wear when we go out. You want to keep all this dress separately. Otherwise, what will happen if you keep the uniform shirt one side and uniform skirt, if it is a girl's skirt, if it is a boy pant, and different areas in the morning or evening, what happens? Is it easy for to take it? No. If it is kept separately, yes, fold it after washing, fold the dress very neatly and keeping it very neatly, and all the dress items separately in separate drawers, it will be very easy or help you to take it. The books also, storybooks, textbooks, notebooks, all are kept together, mixes up. And if you want to arrange the book according to the timetable in your bag, will it be easy for you? Yes, you may feel tired and sometimes you may forget to take the book. But if you keep the notebooks in one area, copybooks in one area, textbooks one area, ref note, and the storybooks that you are reading. If you keep all this separately, it will be very easy, and the room also look neat. That's another thing. It helps. It saves your time, and also you can make that place very neatly if you arrange all the things. So this arrangement and classification is applicable in any places. In bedroom, you are arranging coat, you are arranging the bed, table in one area. And when you go to the kitchen, vessels in one area, cooking powders in one area. All this classification saves our time and also help us to find the things very easily. So based on different criteria or different properties, uses and all, we are classifying the materials. In the classroom also, test paper book. One side you are keeping the GS, one side you are keeping the SS, other English, Malayalam, then copy books in one side. What will happen if you mix all the TP books together? When the teacher asks you to take GS TP book, then you may need to look for every book. Am I right? Yes. To avoid this confusion, you should learn to classify the objects based on the uses, based on the properties. It will help you to save the time and energy. So classification is very important. Before classifying, you should know the properties of that particular substance. Clear? If you want, somebody asks you to make a paper boat, you just make a boat because I want to, the rainy season, now every rainy season is there, I want to just put that boat in the flowing water. Then will you make a boat by using wood? Then what will happen? Paper boat. Yes. Likewise, depending upon the use, boat is made up of what? Wood. But this normal boat, for playing, do we want to make it by using the wood? No. So depending upon the use, depending upon the properties, depending upon the convenience, you are supposed to, or we are supposed to classify the objects. So with this, we come to the end of this chapter. As I used to say every time, please do the activities in the textbook thoroughly. Complete the notes, study it. Anytime you can expect the test paper. Okay, dear children, Please be safe. Until we meet in the next class, it's bye from me. Bye.